We are going to touch on the next part called equations of tangent and normal. Do you all still remember the word tangent? Have you all seen this word called normal before? Yes, in English, probably not in the mathematical term. Okay, so visually I'm going to tell you what are equations of tangent and normal and what we need to do by using differentiation, okay, to find this equation of tangent and normal. Okay, first thing, in an equation of any curve, let's say I have a curve, y is equal to fx. Okay, as mentioned previously, if I want to find the gradient of this particular point, what do I do? You can draw the tangent. But if let's say I want to find the equation of this particular tangent, you cannot draw the tangent anymore. Because by drawing the tangent, that is only an estimation. That is the E-math method. So if I want to find the equation of this tangent, what must I do now? dy dx to find the gradient. So because tangent is a straight line, y equal mx plus c, it means that you have to make use of dy dx, or if not f prime x, to find the value of m, which is the gradient of this particular tangent at this particular point. Of course, you need to know the coordinates of this point accordingly. Okay, so this is the equation of the tangent. Okay, but in this topic, you must also be aware there is this line called the normal. But what exactly is the normal? It is nothing too difficult. If this is the tangent, the normal is just a line perpendicular to the tangent at that particular point. So this will be your normal. Okay? The relationship between a tangent and a normal is it must be perpendicular. Okay? The normal is always perpendicular to the tangent at that particular point. But now, perpendicular. Have we come across something about perpendicular last year between two lines? Can you remember? What relationship? Can you remember? Yeah, m1 times m2 will give us -1. Meaning the gradient of these two straight lines will be equal to -1. In other words, differentiation will only allow us to find the gradient of the tangent. But in order for you to find the gradient of the normal, you need to make use of this relationship. The product of the two gradients is equal to -1. If you are done. Yeah. Okay, so this is the only key idea that we have for this sub-unit. Okay, so based on the questions that we did last year, we're going to do a recap. Okay, so far? Now, straight away zooming into exercise 11E. Page 356. Okay, we are just going to try something easier first. Let's try 1E. We are told to find the equation of the tangent of this particular curve. Oh, E. Thank you. Okay, we are supposed to find the tangent. Remember, whenever you're supposed to find the tangent of normal, they are just straight lines. In other words, it must be of the form y equal mx plus c. Okay? So, if this equation is given to you, you are supposed to find the equation of the tangent. What is the first thing you want to do first? dy dx. So now, besides dy dx, differentiate with respect to x, f prime x, another word that will tell you that you need to do differentiation will be the word called tangent. as well as normal, because you need to go and find the gradient. So like what Aisha just mentioned, dy dx. So Aisha, how to do dy dx here? 2 power 1, right? Okay, remember, go through the basic step again, bring down the power, reduce power by 1, differentiate the terms in the bracket. Okay, so all the techniques of differentiation are very critical. Simplify, and I must let you know, if your differentiation is wrong, the whole thing is wrong. Okay, this is the gradient function. Alright, we would like to be very precise. I do not just want you to write m, because this topic is very confusing. It could be the normal, it could be the gradient of the normal, it could be the gradient of the tangent itself. But remember, immediately after you differentiate, it will be always m of tangent, which is the gradient of the tangent. Alright, in short. So, when x is equal to -1, straight away substitute inside to find the gradient of this tangent. -16. Did I? -1 square is just 1. Okay? So now, y is equal to -16x plus c. We need to substitute a point inside. Am I right to say that? Do you have a point? Sort of. No, we only have a value of x. But I don't have a point to substitute inside. Yes. We must substitute x is equal to -1 inside the original equation again to find the y coordinate. So this is not sufficient. So when x is equal to -1, you need to substitute inside the original equation. So I'll get 16, am I right? So now, at which point? This point called -1 and 16. I can substitute inside here now. And when I do this calculation, I realize the value of c is 0. What can you tell me immediately when the value of c is 0? Yes, you mean? Doesn't cut. No? Cut the origin. Thank you. It cuts at 0. 0 is the origin, not that it doesn't cut. Okay? So the answer is y is equal to -16x. This is the equation of the tangent.